These are the solutions to homework 5.4 day 1. We're going to start with number 7. 4 to the x equals 16. This problem is easiest to solve using one-to-one properties. So we like to rewrite both sides of the equation with the same base. The natural base here to use is 4. So we can say 4 to the x is equal to 4 squared. If these expressions are true, then these exponents have to be equal. So we know that x is equal to 2. Next one, 1/2 to the x equals 32. Once again, we're going to use the one-to-one properties, and we're going to try to write both sides of the equation with the same base. So 1/2 to the x, we can think of that 1/2 as 2 to the negative 1 to the x, and 32 is 2 to the 5th. Power to power, we multiply the exponents. So this is 2 to the negative x equals 2 to the 5th. Now we can equate exponents since these expressions are equal. So that means negative x has to equal 5. So x is equal to negative 5. Next problem, we have 3/4 to the x is equal to 27/64. We can write everything with the same base here, which would be 3/4. So we have 3/4 to the x. 27 is 3 cubed and 64 is 4 cubed. So we can write this as 3/4 to the x is equal to 3/4 to the 3rd. So since we have the same bases, these exponents have to be equal, and we can state that x equals 3. For number 17, the easiest thing to do here would be to move one of these logarithmic expressions to the other side. So I would add ln2 to both sides of the equation. So we'd have ln x equals ln2. Once again, we can use one-to-one properties here. If these natural logs are equal, then their arguments have to be equal, which means that x is equal to 2. For number 19, we have e to the x is equal to 2. There are two ways to approach this. One way would be to rewrite this in logarithmic form, where we would say the base, we'd bring this base over. So we're saying the log is the exponent. So x is equal to log base e, which would be ln of 2, and the problem be solved. Or the second method would be we could take the natural log of both sides. So let's start this problem again. We'd have e to the x equals 2, and then I can take the natural log of both sides because the natural log is the inverse operation of e to some power. So I'd have ln of e to the x is equal to ln of 2. And ln of e to the x, they undo each other. They are inverse operations. So that's going to leave us with x is equal to ln2. Either way, we get the same result. Whichever way makes more sense to you is the way that you should solve it. The next one, ln x equals e to the negative 1st. So one way to solve this is to just rewrite this in exponential form, remembering that the base of ln x is e. So this is one where we could say base to the other side equals next to. So we could say that e to the negative 1st is equal to x. And if we wanted a decimal approximation, so this is 1 over e, which is approximately 0.368 is equal to x. The second way to solve this problem, if you don't want to just rewrite it in exponential form, is to exponentiate each side with a base of e. So I'm going to start this problem again, and I'm going to have ln x is equal to negative 1. And now I'm going to exponentiate both sides with a base e because natural log has base e. And I'm going to have e to the ln x equals e to the negative 1st. On the left side, e to the natural log of something, they undo each other. And that's going to leave us with x is equal to e to the negative 1st. So x is equal to 1 over e, which is the same thing we got when we rewrote this in exponential form. Now we're doing number 23. Log base 4 of x equals 3. So what we can do is rewrite this in exponential form. So we say the base to the other side is equal to next to. So x is equal to 4 cubed, or x is equal to 64. If you don't like that approach, we can exponentiate both sides. So let's try, we'll start again. We'd have log base 4 of x is equal to 3. And now we can exponentiate each side with a base of 4. I'm using base of 4 because I have log base 4. So I have 4 to log base 4 of x equals 4 cubed. These undo each other, and we're left with x is equal to 4 cubed, which is equal to 64. Number 33, we have 2 e to the x equals 10. The first step we need to do is isolate that exponential expression. So divide both sides by 2. We'll get e to the x is equal to 5. And here we have a choice. We can rewrite this in logarithmic form. So I'll do that first. And this is the log is the exponent. So x is equal to log base e is ln 5. That's our answer. And if we wanted a decimal approximation, you can enter that in your calculator. The other option is once we get to e to the x equals 5, we can solve this by taking the natural log of both sides to undo the exponential expression. So we have ln of e to the x is equal to ln of 5. And now ln e to the x is equal to x. Those operations undo each other, and x is equal to ln 5.